So here is a different question. I've given you the mean, I've given you a standard deviation for the sample. I want you to find what the percentage of all scores that are less than or equal to 25 and less than or equal to 14. Give you a little hint. This is the proportion, probability, or percentage, percentile question. So go ahead and work through these and continue playing the video when you've got your answers. All right, so let's see what you got. So here are the z-score calculations for scores less than 14 and less than 25. So less than 25. Again, we have the individual score, which is 25, minus the sample mean of 20 divided by our standard deviation of 5 gives you a z-score of 1. Z-score for 14 is negative 1.20. So now that we have a z-score, what do? We use the table to find the corresponding proportion or probability. So the z-score for 25 was 1, and we look at the table, that gives us a corresponding probability of 0.8413. And for our z-score, that corresponds to a score of 14, negative 1.20, gives us a probability of 0.1158. Now I wanted you to give me the percentage of the scores. So once we have the probability or proportion, all we do is then convert that by multiplying by 100 to give us our percentages. So if we're looking at the scores that are less than or equal to 25, we would then say that 84.13% of scores are below 25 among the sample that had a mean of 20 and a standard deviation of 5. What about if you had a score of 14? Well, 11.51% of scores are below 14. Simply took our z-score, looked it up in the table to give a corresponding proportion or probability, and converted that probability to a percentage to give us our percentage of scores that are below 25 and below 14. So now, what about percent of all scores that are greater than or equal to 14? I'll give you a hint. This is the opposite, I like to say the opposite, of the proportion, percentage, percentile, probability question. What about finding the percentage of all scores that are between 14 and 25 among this sample that has a mean of 20 and a standard deviation of 5? We've already found the percentage of all scores that are less than or equal to 25 and 14, but now I want you to see if you can figure out the percentage of all scores that are greater than or equal to 14 and the percentage of all scores that are between 14 and 25. I'll give you a hint. For the between 14 and 25, you'll want to find the range between the two percentages. So go ahead and work through the two other questions. The percent of all scores that are greater than or equal to 14, and the percent of scores that are between 14 and 25. Come back to this video when you've worked through these problems. Okay, so we've already found this percentage of all scores that are less than or equal to 25 and 14. But what about greater than 14? Remember, I mentioned that this is kind of the opposite of the percentage or percentile question. So what I mean by that is really taking it from 100. So if we know that the scores that are less than or equal to 14 is 11.51, well, we can figure out the scores that are greater than that by subtracting that percentage from 100 to give us 88.49%. Well, why is that? We'll see in just a moment. So what about the between 14 and 25 scores? What percentage of all scores are between these two raw scores? Well, again, all you have to do is take the range of the percentages. So we see that we've already calculated the percentage of all scores that are less than or equal to 25, as well as for 14. So all we'd have to do is take the range of these two percentages to give us 72.62%. So why is that again? Well, let's look at a visual to help us explain why this is. We have our normal distribution curve. We know that underneath this curve contains all possible scores. So it contains 100% of all of our scores. Right here, we calculated the z-score that corresponded to a score of 14, the z-score of negative 1.20. Well, we know that at this point, this is the percentile that goes with that z-score, 11.51%. This is what we found when we calculated our z-score, looked up our probability, or converted that probability to a percentage. And so the way we think about this is that pretty much from the very bottom, the very left tail, we can think of this as 0. And as we move to the right on the normal distribution curve, we're going to slowly add more and more of our possible answers till we get to the far right where we have 100% of our scores. So really from here we have 11.51% of all possible scores are going to be between 0 and 14. Well, when I asked for the scores that are greater than 14, this is what I meant by the opposite. We know that from this point, it's 11.51%, but we know that underneath the entire curve is 100%. All we do is take 100 minus the 11.51% to give us the 88.49% that makes up the rest of this curve, to the right of the line. What about 25? Well, to the left, we have our z-score for 14, and now we have, plotted here, the line and the z-score that corresponds to a score of 25. Well, again, the same principle. If we were to look at where the spot is underneath the curve, looking at it all the way to the left, this is going to make up 84.13%. This is the percentage that we got from looking at the z-score table that corresponded to a z-score of 1, finding that probability of 0.8413, and converting that probability to a percentage. Again, we interpret this as 84.13% of all scores are less than or equal to a score of 25. Well, now that we know this, and we wanted the scores between 14 and 25, well, we know that 14 is right here at 11.51%. We want the distance between the two purple lines. So all we then do is take the difference of 84.13 and 11.51 to give us our 72.62%. So what do you need to know when it comes to calculating z-scores? Well, you need to know how to calculate them by using the formula. Again, I'll be giving you the sample mean, or the population mean, and the standard deviation. If I ask for the percentage, you need to find the probability or the percentage based upon the z-score table and converting it to a percentage. If I ask about less than or equal to a given score, this is where you just look it up in the table and your answer is the probability from the table, or you just convert that to a percentage and that's your answer. It's essentially the left side of the z-score in the normal distribution curve. If I'm asking for something that's greater than or equal to, this is where we think about the opposite, where you're going to subtract your probability from 1, or you're going to subtract your percentage from 100 to find out what scores are greater than or equal to a given score. This is essentially the right side of a z-score underneath your curve. And if I'm asking between two specific scores, you're going to find the two probabilities or percentages for those two scores, and then find the difference, and that's going to be your answer. So here's a video. Feel free to watch this video to help reinforce and look at this in a different way.